In this video, we're going to walk through the process of deploying a Solr cloud or a Solr cluster using the Provision Solr playbook from the Solr repository. As was the case with the other playbooks we've shown you, there are two files that are used to set up the configuration that's passed into the playbook run. The first is a variables file that's application specific, the Solr variables file. These are the parameters, as I've said in earlier videos, that we feel will probably or are likely to not change much from one playbook run to the next. So these are a reasonable set of defaults for the parameters that are required for a playbook run to succeed. Included in that list are the application, which is set to Solr. Probably don't need to change that. The Solr version, which is set to 3.1.1. This is a version of the Fusion distribution from Lucidworks Fusion, the Fusion Solr distribution. It includes Solr and a number of associated tools. So this is the playbook. This is the target of the playbook run, is to deploy Lucidworks Fusion. And the version we're going to deploy by default is 3.1.1. This is a reasonable recent version of Lucidworks Fusion. And it's the version that we've tested against most recently. In addition, we define, as is the case in the other playbooks that we've shown you so far, a Solr data directory, which by default is set to /data. That's the data directory where the data volume is going to be mounted by the playbook when a separate data volume is created. There's a Solr dir. This is the target directory that this Fusion distribution will be unpacked into, and by default it's set to opt Lucidworks. Again, you probably don't need to change it. There's a user and group that are used to own the files that are downloaded and unpacked into opt Lucidworks, to own the files in the /data directory associated with the collections and their metadata, and then of course to run the Fusion service. And we default this user and group to Lucidworks, and you can probably leave that unchanged as well. There is, as was the case with many of our other playbooks, a package list, a Solr package list. These are the packages that must be running for us to start the Solr services, or the Fusion services. And really it's just the OpenJDK packages. You could modify this to add additional packages, but if you do, make sure that these OpenJDK packages are included. There is a private key path that you can set. By default, it defaults to the current working directory. And then a set of parameters that are used to set values in the fusion.properties file, including the default garbage collection type, which is set to G1, the G1 garbage collection algorithm, and some Java options for the Solr UI and connectors services. And these can probably be left unchanged. In addition, for the Solr service to run successfully, we need to increase the number of files that a user can have open and the number of processes that a user can start. And those are set to 32K and 64K respectively. And these are values that are recommended by the Lucidworks Fusion team. Finally, we have our node map. As you've seen before, this is used in the cloud environments to govern how many nodes and of what type are created by the playbook run. And we need to have one and only one entry with a Solr application and a count that's greater than 0. And then lastly, our application security group rules. And this is by far and away the largest set of rules of the playbooks we've written. As you can see, we've summarized up here in the comments for this file what each of these ports are used for. And you can see that there's only two services, the Fusion UI and Fusion connector services, that start up on the external subnet. The remaining services all start on the internal subnet and are used for internal communications between the components that make up the Fusion platform. So that's what the variables file looks like. In addition to the variables file, there is a default configuration file. And this is a file that should be very familiar to those of you who've gone through our other videos or who have used our other playbooks. It starts out with a set of tags and a cloud type, and then the definition of the CIDR block for, say, the VPC in an AWS environment, and the internal and external subnet CIDR values. A username that we're using to access the nodes when Ansible is running SSH commands to access the nodes and execute commands. A type, which is set by default to T2 extra large. And it's important to note here that this is really about as small a node as you could use to deploy the Fusion platform. The Fusion platform consists of 5 or 6 separate Java services, some of which, as I've shown in the earlier discussion of the Solr variables file, have significant heap sizes. So anything, when you look at the Lucidworks Fusion website, they recommend that for a development or test environment, you have at least 16 gigs of memory and 4 processors available. And that's what this T2 extra large type gives you. If you're deploying this to a production environment or for production use, you probably want to increase the size of these instances, perhaps significantly. And then, your region, root volume, and data volume. And again, in a production environment, this data volume probably needs to be increased, perhaps significantly, in order to allow for more room for the collections that you're going to load into your Solr instances. Now that you understand the variables and default config file, let's walk through the playbook and kind of walk you through the process of deploying, or what's involved in deploying our Fusion Solr Cloud instance. The first thing that we're going to do is create a couple of host groups, one for Solr and one for Zookeeper. And this set of tasks are run on the local host. As was the case in all of our other playbook runs, we're going to look at the node map and make sure that there's one and only one node map entry. If there's more than one node map entry, then we're going to fail the playbook run. If there is not a node map entry, then we'll fail the playbook run. Assuming that we have one and only one node map entry, and in this example we do, we have one node map entry asking for a default set of 3 nodes. Then we're going to go out and look at the environment using this build app host groups role and see if we can find matching Solr and Zookeeper instances already running in the environment. And we'll count those numbers, the number of nodes in those 2 groups that come out of this build app host groups role. And this builds the app host groups based on the tags that you passed in the playbook run. And assuming that it finds the appropriate Zookeeper cluster or ensemble externally, it will allow the playbook to succeed. If we're deploying a clustered Solr instance, we need an external Zookeeper ensemble so that those nodes that make up that Solr cloud can find each other and elect leaders and that sort of thing. If not, if it's a standalone, then we do not need an external Zookeeper ensemble. It'll use one if it finds it, but if it doesn't find it, it'll spin up a local Zookeeper instance on that standalone Solr node. Similarly, if we find an existing set of Solr nodes, and this reuse existing nodes flag has not been set to true, it defaults to false, then the playbook run will fail because we don't want to accidentally target an existing Solr cloud just because we happen to have reused the same set of tags that were used when that Solr cloud was deployed. We don't want to target an existing Solr cloud for deployment and blow away the data that might already be loaded in that Solr cloud. So this acts as a fail-safe. It requires the user be very specific and say, yes, I know there's already a set of existing nodes out there. I've checked. They're from a failed deployment or whatever. I'd like to reuse them. But if let's assume that we don't find a set of Solr nodes that match, and I can show you in a moment we won't, and we do find a set of Zookeeper nodes that match, and I'll show you in a moment that we will, and let's assume that we're running in an AWS cloud, then the next thing it'll do will be to call this AWS role to spin up the 3 AMI instances that we need, and then add them to the Solr host group. Once they've been added to the Solr host group, we can target that host group in the second play, which is where we finish off the OS configuration of those nodes using this pre-flight role. As part of that, we will be cleaning up and setting up the network properly to take the 2 network interfaces that we're going to define in the playbook run. and we're going to go ahead and create a unique host name for each of these hosts, and we'll put a file system on the data volume that's been attached to those instances, and then mount that device in the /data mount point. Once that's all done, the third play gathers a bunch of facts from the Zookeeper host group that we found above, and then we go back to targeting our Solr host group. And in this play, we actually use the Solr role to instantiate or to install Fusion onto these nodes and then configure them as a Solr cloud or as a Solr cluster. If you look at the Solr role, the tasks in here, you can see that the process is relatively simple. For those of you who walked through these playbooks before, we first install the required packages, then we add that Lucidworks user and group. We install Lucidworks Fusion from that URL. Go ahead and configure those nodes so that they will start up as a Solr cloud or a Solr cluster. Create our services and enable them. There are more than one, and then start them. So that's the basic flow of the role. So now that you understand the playbook and the role that it invokes, let's go ahead and run this thing. The first thing we're going to do is we're going to duplicate the default configuration file so that we can modify it. And as I've done all along, I'm going to call this config AWS custom. I'm going to go ahead and add a couple of lines to this file to set the private key path to the same private key path I've been using in most of these videos, so that we can find our Zookeeper ensemble. We need to add a couple more tags here. If you remember, we need to set a data flow to pipeline and a cluster to A. These tags, tenant, project, domain, data flow, cluster, all have to match in order to find that existing external Zookeeper ensemble. We don't need to change the CIDR block or the internal or external subnets. We're not going to change the type. What we are going to do is select this specific image. And I'm going to leave the data volume at the default size, although if you're going to load a lot of data into these nodes, you probably want to increase that data volume size, perhaps significantly. So we'll save that file, and then we'll come back over here and run our provision Solr command. You can see that I'm running the playbook as a command using the shebang line that's contained in there, and I'm using my custom configuration file as passing it in with the config file flag as an extra variable. If you look back here in the background, you can see that we do have a 3-node Zookeeper ensemble running, and there is no Solr. There are no Solr instances running, so this should work. We'll go ahead and check for the Zookeeper and Solr host groups. It didn't find any Solr nodes, but it did find those 3 Zookeeper nodes. And now it's going to go through and create the 3 instances by launching 3 machine instances in this AWS environment. It is setting up the appropriate security groups based on the security group rules, the application SG rules that you passed in. And once these AMIs are up and running, it will go ahead and create some 40 gig data volumes and attach those to the AMI instances that were just launched. And I'm going to pause at this point and come back once these data volumes have been created and attached, because this does take a few minutes. And now that our 3 data volumes have been created and attached to our 3 instances, we'll go ahead and create some public internal ENI instances and attach those to these AMIs so that they can be brought in as F1, a second network device. This is going to be the external network. F0 will be the internal subnet. And then we can configure those to delete when we terminate and attach some elastic IPs to them. And then we can add our 3 AMIs to the appropriate Solr host group in this case. Once they're added to the host group, we just wait for those instances to be accessible via SSH, which doesn't take very long at all. And once we know we can access all 3 of these nodes via SSH, we're ready to move on with the rest of the playbook run. Now we can move on to the second play in the playbook, which is completing that OS configuration. And this involves, as I said, creating the script for F1, for ifconfig F1, and then setting up the devices appropriately on the right interfaces, removing the default route from F0 and adding it to F1, and then restarting the network, building the file system on those data volumes, and then mounting them as /data, doing a little reconfiguring of SSH, of the SSH daemon so it's listening on the right network, generating our UUID, and using it to set up our host name for these devices, and then stopping the postfix service and removing the postfix package since we don't need it and it really doesn't make sense to keep it. In the third play, we gather facts from the Zookeeper host group so that we can use them in the fourth play here, where we actually go through the process of installing Solr or Lucidworks Fusion and configuring our nodes as a Solr cloud. As I was showing you earlier, the first step in that process is to install the required packages. In this case, it's the OpenJDK packages. Once that's done, we'll move on to the next step in the process, which is to actually create that Lucidworks group and user. And then we'll go ahead and install the Lucidworks Fusion package on these 3 nodes. And the first step in that process is to download the distribution file, that gzip tar file, to the /temp subdirectory on each of the target nodes. And that takes a minute or 2, so we'll pause here until that's complete. Then we can go ahead and create that directory, opt Lucidworks, and unpack the gzip tar file that we just downloaded into that opt Lucidworks subdirectory, making sure, of course, that the entire thing is owned by the Lucidworks user. Then we can go ahead and finish off the configuration of the files we just unpacked. We'll disable the startup of the local Zookeeper instance and configure the Zookeeper connect string. We'll set up bind and default addresses for the various services, set up Java options for those services, ensure that that /data directory exists on the system, and then get a list of the contents that need to be copied over and move them over from the distribution into the /data directory so that it can be used to store the collections and metadata content. We modify the default install script so that it won't start the services that it starts by default, run that, and then add some limits to the appropriate service files, modify some permissions, create the Fusion services, and then start them. So how do we know that this is actually running? Well, the easiest way to do it is to SSH into one of these machines. Let's say the 79 node. Once we're here, we can use the system CTL command to look at the status of the Fusion service as it's starting up. And you can see that it's already started an agent and Solr service, and it's in the process of starting up the API service, which takes a few minutes. How do I know that it's started the Solr service? Well, I'm going to go to another window here, and let's for the 79 node, let's forward port 8983 to my local host via SSH. So this is a little bit of SSH port forwarding for those of you not familiar with the process. I'm going to connect to the 79 node, and I'm going to forward 8983 in this node to my local host, which should give me the ability to browse to the Solr UI with a browser window. Let's go ahead and just start up another tab here, and we'll go to localhost 8983/Solr. You can see that the UI is up and running. If I go to the cloud here, you can see that I do have multiple nodes running here, the 218, 79, and 70 nodes, and that based on the nodes, it's actually sharded the data in these collections across these nodes. So there's a number of collections already with multiple shards for each, and there are leader nodes for each of these shards that are distinctly different. You know, some of these nodes are leaders for some shards and not for others. So I do have Solr up and running, and it is working as it should. There are a number of services that are started up here. Like I said, the API service takes a little bit of time to start. Once it's started the API service, it fires up the connector service. And once the connector service is started up successfully, the last step is to fire up the Fusion UI service. And this is different from the Solr UI that's provided by this Solr service. This is actually a much more complicated user interface that's run by Fusion itself, or supported by Fusion itself. And you can see I've successfully started the UI on this second port. So let's go ahead and start up a second on port 8764 to, again, let's just pick node 79 for our port forwarding. And now I should be able to say localhost and go to port 8764. And you can see that this does give me the login screen for the Lucidworks UI. And by default, the first time I'm here, I have to set a password. It needs to be at least 8 characters in length. And so I'm going to go ahead and just create that. And once that's done, it will take me to a registration page. And I'm going to go ahead and just skip this registration, and that takes me to a quick start menu. And this is where I can actually upload some sample data or use my own data to actually get started with a new Fusion instance. So as you can see in this demo, we've gone ahead and created a 3-node Solr cloud or Fusion cluster using the Lucidworks Fusion distribution and the provisioned Solr playbook in the Solr repository. We hope you found this demonstration useful, and hopefully we'll see you in the next video. Thanks.